Okay, 9.1 notes, a quadratic graphs a parabola. It's a U-shaped graph. The quadratic parent function is y equals x squared. And what we're going to do is bring up my calculator, and I'm going to go to y equals, and I'm going to type in x squared. And I'm going to graph it, and this is what our parent function looks like. It's called a parabola. It's a U-shaped graph. If I want to fill in the table, I'm going to go second graph. And mine starts at -2, so I'm going to bring it up to -2, and I can see my y is 4, -1 is 1, 0 is 0, and then it starts repeating back up to 4. And if I go back to my graph, there's the 4, 1, 0, 1, 4. That's the symmetry of it. If I go back to my graph, I'm going to mimic the graph here, and I'm going to plot my points: -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And I'm going to draw my line through those points, making our parabola the U-shaped graph. Okay, recall the linear parent function. The equation for that was y equals x. These are the two parent functions we are responsible for the algebra test. The linear parent function went right through the center of the graph at the diagonal with a positive slope. Right, we got parts of a parabola. We have a vertex, which is going to be the minimum or maximum point on the graph. Axis of symmetry, remember it's symmetrical. The left side's going to look like the right side, so we want the line of symmetry. And where the y-intercept is, that's where the graph crosses the y-axis when x is 0. And we have the x-intercept, and that's where the graph crosses when the y is 0. X-intercepts are also called roots, zeros, and real solutions, and they will use these interchangeably on the STAR test. There were 9 questions on the STAR test about quadratics. So if we're going to label our parts, our vertex is going to be the very bottom of the graph. It's a turning point. It's where it stops going down and starts going back up. So this is our vertex, and in this case it's going to be a minimum. Our axis of symmetry is always going to go right through the center of the parabola, and it's always going to go right through the vertex point. So this is our axis of symmetry. And we sometimes shorten that to AOS. And it does have an equation. It's going to be x equals, and that's going to be a number. And it's going to be the x coordinate of the vertex. Okay, y-intercept is where it crosses the y-axis, so that's my y-intercept. And then it has 2 x-intercepts. Most parabolas, you'll either have 2, 1, or 0. Okay, so here's another parabola. This time my vertex is the maximum, so here's my vertex. And this time it's a maximum because it's at the top of the graph. My axis of symmetry is going to go right through there. I'm going to label it AOS for axis of symmetry. Here is my y-intercept where it's crossing the y-axis. And again, I have 2 x-intercepts. That's where they cross the x-axis. Then going back to our parent function of a line, we have parts of a line. We have slope, so that's going to be the change in y, and that's a triangle, over the change in x. Our y-intercept is going to be 0, comma, our number, whatever number it crosses at. And our x-intercept is going to be a number, comma, 0. And this is also called a 0. This was a question on the STAR test last year. What is the 0 of the line? So if I graph that, so from this point to this point, there's my change in y over my change in x. That's my slope. This point happens to be my y-intercept, and this point happens to be my x-intercept. Okay, so we've identified the parts of a parabola, so now we're going to actually identify the different parts. So on this problem right here, our vertex, again, is where it stops going down and starts going up. So that's going to be our vertex, and we can identify that point. That's going to be at 1, 2, 3, down 1 at -1. So this is going to be 3, -1. Is it a maximum or a minimum? Well, that point's at the very bottom of the graph, making it a minimum. My axis of symmetry is going to go right through that vertex point, so it's going to be x equals, because it's a vertical line, and it's going through 3, whatever the x coordinate is. So my axis of symmetry is x equals 3. The number of solutions, 2. We're looking at the x-intercepts for the number of solutions, and my parabola crosses the x-axis 2 times. What are they? Well, it crosses at 2, and it crosses at 4. So my solutions are at 2 and 4. On this bottom one, my vertex is right here. That's at -2, 0. This time it is a maximum. It's at the top of the graph. My axis of symmetry is going to be x equals whatever my x coordinate is, -2. I only have one solution this time. My parabola's vertex is the only thing touching the x-axis, and that's at -2. Okay, back up to the top, my vertex, that's down here at 0, -1. Again, it's at the bottom of the graph, so it's going to be a minimum. My axis of symmetry is going to be my x coordinate, x equals 0. Number of solutions, there are 2. My parabola touches my x-axis at 2 places, and that's going to be at -1 and 1. Those are my solutions. Those are my answers to the parabola. Vertex on the last one is at -1, 2. The vertex is at the bottom of the graph, making it a minimum. Axis of symmetry is going to be x equal to -1, the x coordinate. Number of solutions, 0. My parabola is not touching my x-axis, so this has no solutions, and this circle with a line through it means no solution. Okay, identifying solutions to quadratics given a table of values. Well, we're looking for the x-intercept, and that x-intercept is always presented as a number, comma, 0. So that's what we're looking for in the table. We're looking for a number in the x-coordinate and a 0 in the y-coordinate. So if I look at this table, I see a 0 here, so that's one of my solutions, and I see a 0 here. That's another solution. So remember, solutions is another word for x-intercept, so my solutions are going to be -2, 0 and 2, 0. The second one, what are the zeros? The zeros are referring to the y's. So again, I look for a 0 in my y column, and I see one at -1. That means that's a solution, and 2, 0 is a solution. So my solutions are, my zeros are -1, 0 and 2, 0. And again, 0 is another terminology for x-intercept. This problem right here was on the STAR test. This is a STAR question. If 1 is 1 root for the table above, then what is the value of the other? Well, they're already telling me this is one of the answers, and it's not on the table. So the other answer has to be number, comma, 0. So I'm going to look for the 0, and it's right there. So the other root is going to be 5. Okay, so find solutions, if any. Use the calculator. Yes, we definitely want to use the calculator. So what we're going to do is I'm going to come over here and go to y equals, and I'm going to type in x squared minus 2x minus 3. And then I'm going to hit graph. Now either you can look at the graph or you can look at the table. So I'm going to look at the graph. And again, I want to see where does my parabola hit my x-axis. So it's hitting over here at -1, and it's hitting over here at 3. Those are my solutions. My solutions are -1, and 3. Now if I look at the table, again, I'm going to be looking for this number, comma, 0. So number, comma, 0. So I'm looking for 0 in the y, and I see it at -1. And I'm looking for another 0 at 3. So those are my solutions. Okay, so you can find solutions either looking at the graph and finding out where it crosses the x-axis at, or you can look at it at the graph where the zeros are in the y's. When y is 0, what's x? So x is -1 and x is 3. Okay, so I'm going to go back to y equals, and I'm going to do the next one. Negative 2x squared minus 2. So I'm going to graph it. Oh, I see my parabola does not touch my x-axis at all. That tells me there's no solution. No solution. I will not see a 0 in my table. Okay, number 3. Let me clear that one. X squared plus 8x plus 16. And I'm going to hit graph again. I think I'm going to zoom in on that a little bit. I'm going to change my window. I think I'm going to go -5 and 5. I want to zoom in a little bit on that. Okay, so I can see that it's hitting at 1, 2, 3, 4. That's where my parabola is hitting my x-axis, so this only has one solution, and that's at 4. And I'm going to go back up and do my next one. Negative x squared minus 2x. Press graph. And I see it touches at 0 and at -2. 0 and at -2. Those are my solutions there. And then I've got my parent function, y equals x squared. Hit my graph and I can see it hits at 0, 0, so 0 is my solution. That's different than the no solution. 0 can be a solution. This means there's no solution at all. Okay? Next one is we want to identify the vertex, and again we're going to use our calculator. I'm going to move my calculator over. Maybe. There we go. I'm going to go back to the normal window. I'm going to go y equals, and I'm going to type in my next equation, -5x squared plus 10x plus 3. Okay, and I do want to graph it. I want to see where my vertex is. Okay, remember the vertex is where it stops going up and starts going down. So I'm looking about this point right about here. So I'm going to use the calculator. I'm going to go second trace, and I'm going to come down here. It's a maximum, so I want to go down to 4. So arrow down to 4 and hit enter. You see I have a blinking cursor. Okay, it says left bound. Parabolas are infinite, so they go on forever and ever, so I have to establish a starting point and a stopping point for finding the vertex. So this is my starting point, my left bound, and that looks okay. I think I'll just leave it there. And I'm going to hit enter, and you'll see this triangle pop up. This triangle means start looking for the vertex here. So then I'm going to go to the right bound, so I have to tell it where to stop. Well, I want the maximum point, so I want to be on the other side of it. So this looks like a good spot. I'm going to hit enter. And I have a starting point and another triangle for a stopping point. And it's going to find the maximum point. So then do I want it to guess? Yes. So I'm going to hit guess. And it tells me my maximum is basically 1, 8. And that's my vertex. So I'm going to come over here and my vertex point is 1, 8. Now, my next problem, let me clear that out. I have negative x squared plus 5. So again, I'm going to look at the graph, and I want to go second trace, and this time it is still a maximum, so I'm going to go down to 4. And I want to go to the left of it. That looks good. So I'm going to hit my left bound. That's my starting point. You can see my triangle. That's where I'm starting to look for the maximum. And I want to get to the right, and I want to stop looking for the maximum there.
So I'm going to be looking for the maximum point between these two triangles, and I'm going to hit enter. Now this can be a little misleading where it says x is equal to 2.6086 e to the negative 6. That e to the negative 6 stands for scientific notation, and that negative 6 means there are 6 zeros ahead of that 2. So it's 0, 0, 0, 0, 0, 0, 2, 6, 0, 8, 6. So essentially, if you see an e to the negative number, that's essentially going to be 0. And I'm going to write 0, 5 as my vertex. You can also use your table to find the vertex. What I like to do is I like to look for the symmetry. I like to look for the points that mirror each other. So like -4 and -4 mirror each other, 1 and 1 mirror each other, 4 and 4 mirror each other. And then the one in the middle, that's the vertex. And you can see it's 0, 5. So we can confirm the vertex is 0, 5. The other way to tell, if you're not looking at the symmetry, is where does it stop going up and start going down. So -4 to 1 goes up, 1 to 4 goes up, 4 to 5 goes up, 5 to 4 goes down. Okay, so 0, 5 is the last point that it went up, and then it starts to go down. So that is also another indicator of the vertex, where it stops going up and then starts going down. Okay, W of x, we have x squared plus 4x minus 7. So again, I want to do second trace. And this time, we're going to have a minimum value. So I'm going to find the most bottom of the point. You can see it's kind of coming off my screen here. So I'm going to arrow over until I get to the left side. And I'm going to wait until I see my cursor again. Okay, see my cursor over here. So I'm going to hit enter. And then I'm going to go to the right, so I'm just going to set my right boundary till I can see my cursor again. Okay, that looks good. And then I'm going to have it check. So my vertex, which is going to be the minimum point on the graph, is at -2, -11. So I have -2, -11. Okay, now if you want to look at the table, again, I want to look for symmetry, and I'm not seeing my symmetry here, so I'm going to go back up. There it is. See, I have -2, -2, -7, -7, -10, -10, and then right in the middle is -2, 11. So I was looking for the symmetry. Again, this is where it's going to stop going down and start going back up with a minimum. So it's going down, going down, going down, and then goes back up. So that stopping point is our vertex. Okay, P of x, we're going to have 1/2 x squared plus 2x. That's going to be a minimum, and I can tell because the half is positive. If it were negative, it would be a maximum, so I'm going to go find a minimum. And again, I'm going to arrow over to the left side, hit enter, then I'm going to arrow over to the right side of my bottom point and hit enter, and then it's going to find it for me, and that's going to be at -2, -2. Okay, again, if you want to look at the table, I want to find the points of symmetry, and I can leave it here. I've got 2.5, 2.5, 0, 0, -1.5, -1.5, and right in the middle is -2, -2. It's also where it stops going up, stops going down, and starts going back up. So it goes down, 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 and then back up. So that's also an indicator of my vertex. Okay, G of x, I have -x squared. Being that it's negative, I can already tell it's going to be a maximum, plus 6x plus 1. So I'm going to go ahead and do second trace, and I'm going to do a maximum 4. And I'm going to get a little closer. So that's my left side. That's where I'm going to start my vertex. Search. Come over here to the right side. I'm going to end it there. And I get 310. So 310 is going to be my vertex here. And again, if I look at my table, I want to find the symmetry. Okay, and I don't see that here, so I'm going to go down. Okay, there's where I start to see it. See a 1 and a 1, a 6 and a 6, a 9 and a 9, and then a 10. Okay, again, that's where it stops going up and starts going down. So it starts going up here, going up, stops going up, and starts going back down. So 310 is my vertex. Now we have the parent function, x squared, and that's going to be a minimum. So I'm going to choose minimum, and I'm going to go to the left side of it, hit enter, go to the right side of it, hit enter, and have it guess. And it's going to be, again, this is misleading. Looks like it starts at negative 2.6, but that's got 6 zeros ahead of it. And this one has 12 zeros ahead of it. So essentially, that's going to be 0, 0. The vertex is going to be at 0, 0. And if I look at my table, and I find my symmetry, there I've got 9 at the top, 9 at the bottom, 4 in the middle, 1 in the middle, and then 0 is right smack dab in the middle. So 0, 0 is my vertex. Okay, critical thinking. This will be on the test. Star it. It will be on the test. Alright, so we talked about this. If the solution to the quadratic functions are 1 and 5, then which of the following points could represent the vertex of the graph? And we talked about how the vertex is right smack dab in the middle of the graph. So it's going to be right in the center. So if my solutions are 1 and 5, I need a number that's right in the middle of them. Well, the number that we find right in the middle is called a median. So if I write out all of my solutions between 1 and 5, 1, 2, 3, 4, and 5, and I use the median, which means I cross out the front, cross out the back, cross out the front, cross out the back. The number in the middle is going to be right smack dab in the middle of those solutions. So my vertex should start with a 3. Well, A starts with a 2, so I can eliminate that. B starts with a 4, I can eliminate that. That one starts with 3. D is 2.5, and E is 0. So this is going to be the x coordinates since the solutions are x-intercepts. So it's going to be C. So we usually use the median, and if you have two numbers in the middle, you add them up and divide by 2. Okay? Investigating changes to y equals ax squared plus c. We did something similar with our linear parent function as well, where we changed the slope, which this is not the slope, this is the a squared, and then the c, which was equivalent to our y-intercept. When the x term is missing, so you can see we're missing bx in the middle, that means our axis of symmetry is always going to be x equal to 0. So we want to observe what changes occur when we make changes to c. So here I have my parent function, y equals x squared. Okay, what happens when I add 1 to it? X squared plus 1. Okay, well, it just moved up 1. What happens if I change it to 2? It moved up 2 units. What happens if I change it to 3? It moves up 3 units. What happens if I change it to 4? It moves up 4 units. What do you think is going to happen if I change my sign and go negative instead of positive? Oh, it went down 4 units. Well, here's minus 3. It went down 3 units. So the conclusions that we make is the parabola shifts up or down. Okay, so that's any time we change that number on the end here. Okay, it goes up if it's positive and down if it's negative. And that's similar to what we changed on our y-intercept on our linear parent function. Okay, well, what happens when we change A? So let me come back up. And we're just going to change A. So that number in front, I'm going to change to 2. Okay, Okay, so there's the original. It got squished in a little bit. We call that narrower. It became narrower. Well, what happens if I change it to 3? It's still narrower. What happens if I change it to 4? It becomes even more narrower. What happens if I change it to 5? It becomes even more narrow. So as we increase A, the parabola becomes more narrow. Well, what happens when I change to a negative? So now I have negative 5x squared. It's still narrow, but this time it flips over the x-axis. So the conclusions that we can make is the parabola becomes more narrow, and this is the terminology used in STAR, and the negative reflects over x-axis. Okay, so that negative does have an effect. It flips it over the x-axis. Okay, well, now we need to see what happens when we change A again, but this time to a fraction. So what happens if I do 1/2 x squared? Here was the original, and here's the half x squared. So it made it wider. Okay, well, what if I change it to 1/3? It becomes even more wider. What if I change it to 1/4? It becomes even more wide. What happens if I change the sign? Well, it stays wider, but now it flips. So our conclusion, the parabola becomes wider, and the negative reflects over the x-axis. Okay, now for the bottom part, and we're not going to use our calculator. We want to identify what changes occur when we change A and we change C. So our parent function is going to be the y equals x squared, and I want to know how this function changes that. Well, this number right here is a 2, so that means it's going to become narrow. So it's going to become more narrow. And if we change that number on the end to a negative, that means it's going to go down 5 units. So those are the changes from x squared to 2x squared minus 5. The number in front of x squared is going to make it either narrower or wider. And then the C change is going to make it go up or down. So in this case, it's negative, so it goes down. Okay, y equals negative 1/4 x squared plus 3. Well, we know if we change the negative, that's going to make it reflect. So it's going to reflect over x, over the x-axis. That 1/4 we looked at, that made it wider. And that plus 3, well, that makes it go up 3 units. Okay, so I don't need to graph it. I can tell by looking at the numbers what's going on with the graph. Y equals negative 5x squared. Well, that negative makes it reflective. So it reflects. And that 5 makes it narrow. Okay, 7/5. Well, what we've noticed is if our A was greater than 1, it got more narrow. And if our A was less than 1, but greater than 0, it got wider. Well, 7/5, would
that be over 1 or under 1? 7/5 would be over 1, so that would make it more narrow. And then that negative 13 makes it go down 13 units. Y equals negative x squared plus 4. That negative makes it reflect. And that 4 makes it move up 4 units.